Hello, and welcome to the 4.1 video. If you're wondering why we went from 1.2 to 4.1, it's because I took out a few lessons for the online learning, and also there's just so much about functions that it's just kind of a little bit of everywhere. Anyway, so today's video, we are going to be going over pages 1, 3, and 4 from this packet. You can just ignore the others. We will be going over pages 1, 3, and 4. Now let's get started. So as you take a look, you may notice that this section is about function composition. I always think about this like Inception or like Russian nesting dolls because it's just something inside of something else. So here we have f of g of x. That's the same thing as, again, f of g of x. We can see this g of x is inside this f of x. Now, this o right here, I keep saying of instead of multiply. Very big, important part here. This round circle that you see on all the examples below, that does not mean multiply. That is not what that means. We are not multiplying here. I see 1 or 2 students every year who make this mistake on a test. Please don't let that be you. This means compose. So put a function inside of another function. So I'm going to show you a few examples of that. I'm going to go over A, B, and C with you, and then I'll let you do D, E, and F on your own in the go-formative that we will work on tomorrow. So I'm actually going to start with problem B, just so you can see what that looks like with one function instead of a number, instead of another, and then we can go through and plug in equations. So again, as you may notice, there are 2 different notations for that. I will be showing both kind of interchangeably, but if you prefer one over the other, just feel free to keep changing it to that. So for instance, I'm going to say that, again, for B, f of g of x, that's the same as f parentheses g of x. And you may notice that the g of x function is inside the f of x function. So instead of f of x, we're replacing the x with g of x. Kind of like how if we find like f of 1, we're plugging in 1 for that x. So what this is going to look like is it'll be 3 parentheses, and then instead of x, it'll be a 3x, because that is our g of x function, squared, minus 1. So this is me taking the g of x function of 3x and putting it inside f of x. And then from here, we must simplify best that we can. So let's see, when we square 3x, we get 3 times 9x squared. Please remember to also square the constant, or pardon me, not the constant, the coefficient. So it would be 3x times 3x, giving us 9x squared, minus 1. And then I will multiply in the 3, giving us 27, oops, that's not a 7, that's an x. 27x squared minus 1. Since there's no numerical numbers that we were plugging in, there's nothing to solve for. This is it. Now, if you are using composition as well as evaluating, like plugging in a number, like you are for part A or for part C, there's actually a few different methods you can go about doing that. So I'm going to show you 2 different methods with part C right now, and then I'm going to show you another method with part A. So I just want to show you, your work may not look exactly like your neighbor's, but there are several different ways to do this. As long as you are showing your work and not just giving me the answer, that's all I care about. So one of the ways to deal with composition as well as evaluating, there we go. So for part C, again, I'm going to do this in 2 different ways. So this is the same as g of 2. So one of the methods I can do is I can find g of g, just like what we did up above with no 2, and then plug a 2 in at the end. So I can say that g of x, because I can plug a function into itself, is 3, and instead of x, it'll be 3x. So I have plugged my g of x into my g of x. Oops, giving myself 9x. So that's g of x. That x did not need to be in parentheses. There we are. And then from there, we can plug in a 2. So if I plug a 2 into that, I get 9 times 2, or 18. So we can say that g of 2 is equal to 18. So we can do the g of x and then plug in a 2. You can also find g of 2. I'm actually going to do this in a different color to show that it's different. Let's do blue. So I can find g of 2, that inside function, and that's going to be 3 times 2, or 6. So that's kind of the internal part right here. And then I can take that number and plug that into g of x. So g of 6. So that came from right there. And that's going to give us 3 times 6, or 18. So we should be getting the exact same answer when we do this. So g of 2 is equal to 18. So you can either find g of x first and then plug in the number, or you can look specifically just at the inside function, take whatever that value is, and plug that into your, the inside function, and take that and plug that into your outside function. So these are two separate methods that you can use when using composition as well as evaluating. And what we can do for another method, which I'll show you in part A, is just doing this all together, is doing g of 2, or in our case, f of g of -1, all in one fell swoop. So let's move up and take a look at that. So this is the same as f of g of -1. So something you can do is you can take -1, plug it into g, and then take that value and plug it into f of x. You can take the f of g of x that we have down below and plug in -1. That will work. Or we can do it all in one fell swoop. So we can say this is 3 of -1 squared minus 1. So you can see right here's my -1. Here is my g of x surrounded by my f of x. So if you want to do it all in one fell swoop like that, you can, but there are other methods as well. So from here, order of operations, got to deal with my parentheses first. So 3 times -1 is a -3 squared minus 1. -3 squared, please be careful about how you do this in the calculator. It is -3 times -3. A negative times a negative is always going to be a positive. So this is going to be 3 times +9 minus 1, or 27 times 1, giving us 26. Now again, you may have used a different method for this, but you should still be getting the same answer. So feel free to try this on your own in a different method, or go back and check your work. We are going to move on from this section and go to page number 3 and start with example 3. I will let you know right now that example 4b is going to be in the Go formative, but we're going to do example 3 and example 4a together. So let's see, example 3 asks us to find f of g of x, giving us f of x and g of x, both fractions, and then state the domain of f of g of x. So let's get this going. So we're going to have f of g of x, that's the same as f parenthesis g parenthesis x, also known as f of g of x. So this tells me that my g of x needs to be inside my f of x. So wherever I see an x for my f function, that's where I'm going to put my g function. So that becomes 1 over, I see an x, so that's going to be 4 over x plus 2 plus 4. Oh, look at that. It looks fun. So it's going to be our goal to simplify this as much as we possibly can. So we need to find a way to get rid of this, looks like a triple fraction, as well as add that 4 in some way. And something that I know is in order to add or subtract fractions, we have to have a common denominator. Now, I look at this 4 in the denominator and I'm like, that's not a fraction. But you can actually take any number and turn it into a fraction by just sticking it over 1. 4 divided by 1 gives us 4. So if we turn that into a fraction that way, and I go, okay, now I need common denominators, I'm going to multiply this by x plus 2 over x plus 2. Now, the reason that I can do this is because this is just like multiplying by a big old giant 1. And multiplying anything by 1 keeps the value the same. We're just making it look different. So this is going to become 1 over 4 over x plus 2 plus 4 times x plus 2 over x plus 2. And we're like, ah, yes, look, they now have common denominators. We can add these together. So this becomes 1 over 4 plus 4 times x plus 2 over x plus 2. And now I'm going to go through and distribute this 4 up here. We get 1 over 4 plus 4x plus, is it 8? Over x plus 2. And that becomes 1 over 4x plus 12 over x plus 2. Now, there's a few different things you can do here. Since it is 1 over a fraction, we can just flip the denominator and be good there. But you can also write this out the long ways. So that's what I'm going to do. I say, hey, this is the same thing as 1 divided by, and actually I'm going to move up this work just a little bit so we can have more space. So I'm going to show my communication, say, hey, I'm going to continue my work over here and say that this is the same thing as 1 divided by 4x plus 12 over x plus 2. So remember, if you're ever not sure what to do with so many fractions, write it the long ways instead of the tall ways. That's going to help. So this becomes 1 times x plus 2 over 4x plus 12. And 1 times anything is just itself. So we are actually left with x plus 2 over 4x plus 12. Yay! So it took a little bit of work, but we were in fact able to simplify this. But this wasn't the only question asked. We also now have to look for the domain, which I'm going to do in blip. So state the domain. So when I look for the domain, I see, okay, in our final answer over here, we're dividing by something. We know that's not supposed to be 0. So let's see, we know that 4x plus 12, that's not supposed to be 0. So we're going to have 4x is not supposed to be negative 12, or x is not supposed to be negative 3. But this is not our only restriction. We have to go back to our original work, look through, see if there's any other time we're dividing by something else, and there in fact is. Most of the time, we're dividing by a x plus 2. So as we go through, I can pick anywhere on here. I'll just pick over here because there's some space. So I'm going to say, hey, that x plus 2, that also can't be 0. Because even though it's not in our final answer, if we were to do any work along the way, we still can't have that be 0. So we get x should not equal negative 2. So I'm going to take both of my restrictions of x cannot be negative 2 and x cannot be negative 3 and put those into our domain. So our domain, we're going to start with our very smallest value at negative infinity, go all the way up to negative 3, but we're not including negative 3. So our x value can be a negative infinity to negative 3, or from negative 3 to negative 2. So again, no bracket because it's not equal to. Or it can be from negative 2 to infinity. So we're holding out those separate intervals for where it could be. Take a moment. Feel free to rewatch this section if you need to. But we are about to move on to example 4, part A. All right. Example 4, part A, let f of x be 1 over x. Let g of x be square root of x minus 1. So again, we are finding f of g of x, which is the same as putting those in those parentheses. So again, I'm just showing you both ways. So g is the inside function right now. So I'm gonna write out my f of x function because that's the outside one. 1 over square root of x minus 1. I'm putting that into my g of x function into my f of x function. Now, technically, we can't really simplify this anymore, but mathematicians do not like to have square roots or radicals at the bottom of fractions. This is because older calculators were not able to compute when there was a square root or radical at the bottom of a fraction in the denominator. And they can now. I mean, our graphing calculators are super magical, but we still like to hold that practice in place. So we are in fact going to take the extra step of rationalizing the denominator, is what that's called. So to rationalize the denominator, you're going to multiply top and bottom by whatever the radical in the denominator is. So in this case, it's square root of x minus 1. And we're going to multiply that top and bottom because, again, that's like multiplying by 1. It's just changing how it looks. It's not actually changing the value. So when we do that, we get the square root of x minus 1 over just a simple x minus 1. Because remember, square root of 3 times square root of 3, just going to give us 3. Square root of 4 times square root of 4, just going to give us 4. Square root of x minus 1 times square root of x minus 1 is just going to give us x minus 1. So this is actually as far as we can simplify that. Nothing's going to cancel out. But we still have to find that domain. Oops, that's still in black. Color code. That's still the domain. So when I take a look at this, I see that we do in fact have two restrictions. We have a restriction over here in the denominator saying, hey, you can't divide by 0. So x minus 1, that's not supposed to be 0. And we have x is not supposed to be 1. Okay. And then if we look in the numerator up here, that's a square root or an even root. So we're going to say, hey, everything inside here has to be greater than or equal to 0. So when I work through this, I see that, okay, x has to be greater than or equal to 1. So I'm going to have to take all of this information and combine it into one domain. Now, I look at this and I go, okay, I see that we're not supposed to be equal to 1 here, and we have an x is greater than or equal to 1 here. So in order to bring those together, I'm just going to take the or equal out of the greater than or equal to. Bring us to the domain of x is greater than 1. So that's what that combination is going to look like, telling me that we're going to start with the parentheses at 1, and then since x is greater, I can do 2, 3, 4, 5, 17, all the way up to infinity. Now, if we didn't rationalize the denominator and we still went through with finding the domain with the square root in the denominator, we should still have the exact same thing. Take a look at this. Let me know if you have any questions. We're going to be moving on to page 4, and that is the last page we will be going over today. Moving on to page 4, we see that there's actually only one example. So we're going to work through this example and then be done with the video. So it gives us an f of x and g of x, and it asks us to find both f of g of x and g of f of x, and show us that when we simplify them down, they equal x. So let's try that. Let's go to black. Let's see, f of g of x, remember it's not times x, it's of x, is going to be the same as f of g of x. So I'm going to take that g of x and plug it inside my f of x function. And I can highlight this so I can show you. So it's going to be 2 my f of x times 1/2 x minus 1 plus 1. So we can see that inside here, this g of x function got put inside our f of x function. That's where that went. And now we must simplify. So very important here, your order of operations, deal with everything inside the parentheses first. 1/2 x minus 1. I can distribute that 1/2 if I want. I can also, since this 2 and this 1/2 are being multiplied together, I can multiply these in and say that this is, there we go, x minus 1 from that parenthesis, plus 1 from outside of the parenthesis, and negative 1 plus 1. That gives us x. Yay. Okay, excellent. If you were to go the route of multiplying in the 1/2 and then multiplying in the 2, that will work as well. Just keep in mind to multiply the 1/2 to the x and the negative 1, not just the x. So this is the first part. This is the f of g of x. But now we need to go the other way with, g of f of x, where g is now the outside function. And again, I can highlight to show how this worked. So this will be 1/2 times 2x plus 1, so that's me plugging in my f of x function for where there's an x, minus 1. So we see that this f of x function here got plugged in right here into our g of x function. And again, let us simplify. I see here inside our parentheses, we have a +1 and a -1. So let's do that. There we are. So this becomes 1/2 times just a 2x, and 1/2 times 2 gives us 1, leaving us with just x. So we were able to show that f of g of x as well as g of f of x simplify down to x. Something very important, this is how we can verify whether two functions are inverses of each other. So this is how we can verify whether two functions are inverses of each other. Quick forecast, 4.2 is all about inverses. We're going to be using composition a lot to prove whether or not two functions are inverses of each other. All right, well, I look forward to seeing you tomorrow. Let me know if you have any questions.